Okay, hey guys, today we're going to talk about solving trig equations. For those of you who have been keeping up with this stuff, thank you so much. For those of you who are a little behind, please take some time to get in those previous two worksheets, as it really leads to what we're talking about today, and then what we're going to be talking about next time as well. Okay, so today we're going to talk about two pieces. One, how do we solve trig equations using a calculator? And then number two, how do we solve basic trig equations without a calculator? And we'll walk through 3 examples here, then you'll have homework to do another 6 problems. So if you get this, it should go pretty quickly. If you don't, send me an email. I'll try to sort you out as quickly as I can. Okay? All right, here we go. So first thing is we're going to use graphing calculators to solve trig equations. So take out your TI-84 or whatever you have. I'm going to use a TI-84 to model this. If you don't have a TI-84, hopefully you know how to do the same things on your calculator. All right. Before we even get started, I want you to check your mode. We're going to only be solving things using radians, so be sure your calculator is in radians. Right now mine is in degrees, so I'm going to change that to radians. And then I'm set for what we're going to do next. All right. So the first thing we're going to look at is this equation here. 2 sine x minus cosine x equals 4 minus x. And we're going to solve it for all values of x between 0 and 2 pi. All right? So this is our goal. Now, in order to do this, there's really 3 things we need to think about. All right? The first one is we need to think about how are we going to solve this equation. And the easiest way with the calculator is just to take the 2 sides and put them into different parts of your calculator. So I'm going to put the whole left side in y1. I'm going to put the whole right side in y2. So I'm just going to go to y equals, and I'm going to enter these things. So 2 sine x, 2 sine x minus cosine x on 1. Then I'm going to hit return, and in y2, I'm going to enter 4 minus x. That's it. All right? So I have these entered. Now, the next thing I need to think about is, what is my domain? And in this case, I'm given a pretty clear domain. I don't have to really think about what it is. It's right there. My domain is all x values between 0 and 2 pi. All right? So instead of getting every possible answer, which there's actually an infinite in this case, and trying to decide which ones work, I'm going to actually just adjust my window, and instead of the x going from negative 10 to 10, I'm going to adjust it so it goes from from 0 to 2 pi. Excuse me. So there we go. The scale doesn't matter. The y min and max doesn't really matter, although we know for sine values we're not going to get that high as 10 and negative 10, so I'm actually going to change this from negative 3 to 3, just so I can see a closer part. If you don't change that and you keep your y going from negative 10 to 10, you'll see the same thing I see. You'll just also see more blank space above and below it. All right? So now I've adjusted my window to fit my domain, and the last thing then is I'm going to actually look at the graph. And what I'm interested in with this graph then, here's my first part. 2 sine x minus cosine x, and there's 4 minus x. What I'm interested in here is where do these cross, right? And there are 3 places. 1, 2, 3. All right. Now I'm going to look at these one by one and find the intersection because I can't find them all at once, unfortunately. So the way we're going to do it is second calc and then intersect. Now, for the first part, I'm going to look at this first intersection point. So it's going to ask me for my first curve, second curve, and guess. Remember, first curve and second curve just means you need to tell the calculator which 2 lines do you want to find the intersection of. Now, that's easy in this case because we only have 2. We have the curve of 2 sine x minus cosine x, and we have the line 4 minus x. So choose one, then choose the other. Doesn't matter which order. Now, the guess matters in this case because we need to actually tell the calculator which one of the 3 intersection points we're looking at each time. So the first time, I'm just going to choose the one on the far left. So move my guess towards that, hit enter, and here's my answer. Now, notice for this problem, we're finding where 2 sine x minus cosine x equals 4 minus x, right? And we're told we want to know for x between 0 and 2 pi. So really, our solution is not both coordinates of this point, but it's just the x in here. So my first answer then is just going to be x equals 1.82 if I round to 3 significant figures. Okay, same thing again. Whoops. Second trace, intersect, and again, first curve, second curve, and a guess, and now this time I'm going to find this middle intersection point, and there it is. The x-coordinate, again, right here, gives me 3.28. Right? So there's my second intersection point. Finally, one more time. First curve, second curve, and now the guess, this time, I need to make close to this point. That's close enough, just so it knows it's going to go to this intersection point as opposed to the previous one. All right? And there's the answer, 5.81. If I round to 3 significant figures, so 5.81. So there's my solutions. All the values between 0 and 2 pi are these 3. Okay? So that's how we solve using a calculator. And now I'm going to look at what do we do if we don't have a calculator. So we'll forget the calculator now and we'll just look at solving these algebraically. When you're solving things algebraically, there's 2 things you need to remember. All right? The first one is, how do you solve a basic equation? All right? And I think you know how to solve this. You're going to add 3, divide by 2, and then you'll get your answer. The goal is to get x by itself. The same thing with the trig equation. The goal is to get sine x or cosine x by itself. And then we can do one more step, which is using sine, cosine, or tangent values of special radian measures. And what I mean by those special radian measures is those values we always talk about. 0, pi over 6, pi over 4, pi over 3, pi over 2, and then so on into the second, third, and fourth quadrants. All right? So here's a problem. We want to solve 2 sine x minus 1 equals 0 for 0 to pi. So the first thing, I'm not going to worry about the domain. I'm just going to solve this equation. So add 1 to both sides. Divide by 2. And here we are at sine x equals 1/2. Right? Now, thinking about a unit circle, I know that sine x equals 1/2 when x is pi over 6. Right? But now I need to think about, are there more answers in this given domain? So now I need to think about this 0 to pi. So let's think about a unit circle for a second. Pi over 6 is something like this. So here's my angle pi over 6. And now I know my domain is 0 to pi, which means all the way through the second quadrant. All right? Now I need to think about, is there another positive sine value in there? And I know that sine refers to y-coordinates. So I can see that both the first and the second quadrant have positive y-coordinates because they're both above the x-axis. So that means there's going to be another angle over here that's just pi over 6 units away from pi. Well, pi is 6 pi over 6, so pi over 6 short of that would just be 5 pi over 6. So there's my second answer. So I have 2 answers for this problem. I know I'm done because anything else would be in the third or fourth quadrant, which would be more than pi. So there's the first one. We're going to look at one more that gets a little bit more complicated for a couple reasons. One, the equation we'll look at here is going to come out needing a little bit of simplification before it becomes clear. And then two, you can see here we have a domain going from 0 to 3 pi. So then we're going to have to think about what that means. But let's start by solving this. So first thing, again, anything that's not connected to the cosine or sine function, let's get rid of that. So subtract 3 from both sides, and now we have root 2 cosine x equals negative 1. Now get rid of that root 2, and now we have cosine of x equals negative 1 over root 2. Now this might not look familiar to you, but if we were to rationalize the denominator, so multiply by root 2 over root 2, what we end up with now is cosine x equals negative root 2 divided by 2. And that is something that should seem familiar to you. All right? Now there's a couple ways to think about this, but the way that I think about it is I'm going to first think about this equation here, which is cosine x equals positive root 2 over 2. Okay? And I know that in that case, x is pi over 4. So what I'm going to do here is I'm going to call this a reference. Okay? That's my reference for this problem. So I know pi over 4 can't be an answer because I have a negative here. But I know there's going to be some reference of pi over 4. So now what I'm going to do is, again, I'm going to draw a little unit circle. Here's my pi over 4 reference. But now I need to think about where is cosine going to be negative. Cosine, remember, refers to the x coordinate. So I need to think about where is the x value going to be negative. And x is negative everywhere to the left of the y-axis. So I know it's going to be negative in these two quadrants. So I'm going to have these two values over here that are pi over 4 short of pi and pi over 4 more than pi. Pi over 4 short of pi is just going to be 3 pi over 4. Pi over 4 more than pi is just going to be 1 extra pi, which is just 5 pi over 4. Excuse me. So now if I was going between 0 and 2 pi, I would have all my answers, I'd be done. But now I need to consider the fact that my domain is all the way from 0 to 3 pi. 0 to 3 pi, well, remember this is 0 or 2 pi. This is pi over here. So 0 to 3 pi means going around one time and then coming around again another half. All right? So I know my two answers for this problem are these two. So I need to think about, does it cross again? And the answer is yeah, it crosses this line here twice. So that means my answer here is going to be 3 pi over 4, 5 pi over 4, but then again, I'm going to go all the way around the circle from 3 pi over 4, and I'm going to get back to this again. So I can think about this as 3 pi over 4 plus 1 full revolution, which is just another 2 pi. Right? 3 pi over 4 plus 2 pi. If I wanted to write 2 pi as something over 4, it would be 8 pi over 4. So I can think about this as 3 pi over 4 plus 8 pi over 4, meaning my final answer is, 11 pi over 4. And those are my final three answers. All right, so using what I know about a unit circle, using what I know then about going more than one revolution around, and I can get all the answers I need. All right, so those are 3 examples that should help you solve these problems. Like I said, if you have questions, let me know. Now, if you look on Haiku, there's a homework problem with about 6 problems on it. Try those. I'll post the answers on Tuesday so you can check. All right? Good luck.